All right, let's get started on these radios. By the way, I had that colonoscopy Friday. They found diverticulitis, holes in my intestinal wall, which accounts for almost 100% of my pain over the last 2 years and bleeding in that area. The radiation scarring on my bladder accounts for the bleeding in the other area. I think we finally got it nailed down. I've got to go see a dietitian about combating the diverticulitis. These two radios aren't exactly the same. What I would call the ground station is just a little bit larger than the air unit. I hope you can buy them, not in a pair like this. I don't want to open these up. Don't want to cause any problems. Not that I would, but if I can get some more, they're out of stock on the site right now. Hopefully I can buy just the air unit, or if I have to buy another ground unit, I can open it up and make it a naked. Although I do like the Faraday cage type outer coating. I think the extra size is just because of this old USB type port versus the micro USB. So we'll be looking at that in the future. I've always had good hopes these would work. I've read in the documentation recently they're only 200 milliwatts, but it's a different radio frequency. There is also a difference in weight, of course. The larger one weighs 37 grams, whereas this one weighs 29. Difference of about 8. These 2.4 gigahertz antennas weigh 25 grams a piece. I was a little bit shocked by that. That's quite a bit. Used to, years ago, really fight for 100 grams on your overall project. That would just be, 2 of these antennas would be half of that. So there's that one with its 25 gram again. Again, still shocking that they're that heavy, but they're quite bulky. There may be some aftermarket fixes for that. So that brings the total weight of this one to 60 grams and this one to 53 grams combined unit and antenna. Okay, real quick, let's look up at their website. This is the web page where I bought it, and you notice right now they're sold out. Hope that changes. Hope it works. So this has everything you need on it. USB firmware updates, etc., etc. You just need to scroll down and download your documentation. Let's see, where is it? Yeah, do that there, Silvers. Boy, here we go. Downloads. Just screamed right by it. 2.4G Datalink downloads. So this is SIYI. I'll never pronounce that. I don't want to butcher it. Assistant. Download that zip. There's also SIYI Q ground control installer here. I'm not sure if that's just a straight link to or download of Q ground control. That'll be interesting to find out in the future. I'm not going to delve into that right now, but it's also on their site below the assistant. Then here's your user manual, PDF form, and the latest firmware from 1/20/21. Wow, that is quite a bit of time ago. I'm surprised I didn't find these radios sooner. But if you download that assistant, you'll find it right here. And this is about all there is to this creature. And when you load it up, with one of the radios attached to USB and turned on. Right here in this upload section, you see the device, its serial number, boot program version, and firmware version. And then this is where you would put in the file name to upgrade it. The rest of this setting seems to be for a gimbal they also sell, because this has like 16 different pulse width, a PWM, a low, a mid, and a high for like on a servo channel, etc., to move the gimbal around, it looks like to me. I don't see anything here that would reference these radios. And this is, of course, the gimbal control and gimbal calibration. Only thing I see here that, as far as this radio is concerned, is this, a firmware upgrade. These are 2.4 gigahertz radios. There's no changes to any of the setup, it looks like. Shouldn't be really. Operates on one frequency. Shouldn't be much. At one power, 200 milliwatts is what I see here. We'll look back at that real quick. So there's not much to them. Baud rate either 57600 or 115200. 5 volts. They give you the weight without the antenna. Air unit. They're not telling me the power output there, are they? It may be in there. User's manual. So we'll just go look at the user's manual real quick. Again, these are the radios. The ground unit has a old-timey regular USB connection, but the air unit has a micro USB. This will not upgrade or look at the firmware. There's a connection on the side, another micro USB on the other side where you do that. There's a bind button on the other side of both of these two. These are the ports where you connect the flight controller. This has those same ports, so again, this might be able to be opened up and be made naked, although you wouldn't have the case around it anymore to block spurious frequencies from coming in or going out to other things. But you might be able to convert this into an air unit in part by taking it out of the case, because I think this is going to be an attached daughter board that's just a lot of components for this USB type, whereas this one was probably just a connector on the board itself. Again, not going to open them up for a while. If we scroll down to this, this is the port on the side, the light on top, data 1, data 2 out. Micro USB over here for firmware upgrading, although this one I think will work with the air unit. This one will not with the ground unit. It doesn't even see that it's there with that assistant I showed you. And here's the specifications again. Oh, this says 100 milliwatts. Again, because of the frequency we're working at, this might actually go a good distance. It's supposed to go 10 miles with this low of an output due to the frequency it's operating on. It says 9.3 miles here. We're going to see. Don't see anything else in this that makes much difference. nor in this packing list. This right here is about the only, I think, the only information you get on how to connect this to a flight controller. And I haven't quite interpreted this yet, which we'll see in a second when I show you this on the units themselves. Got a plus, a minus, a transmit, and a receive. There's no clear to send and request to send on these radios like there are some. Just doesn't exist on this one. It shows the VCC, I would call it, or supply voltage is a red wire. It shows this green wire, which doesn't exist on the unit itself. It's a black wire. There is a blue wire and a yellow wire. I don't know if the blue's going to be associated with transmit and the yellow with receive, or if that's going to be different. We'll find out when we hook it up. But right now it says the transmit is a blue wire and the receive is a yellow wire, and it shows here how they have to be crossed over. So transmit goes to receive on the flight controller, and transmit on the flight controller goes to receive on this unit so they can communicate fully. Continuing down through this, it talks about the lights on the front. Talks about where the antennas propagate from. They're always weak, 90 degrees, straight up, straight down. Quite a few dB loss there. So this would be showing you to rock your ground station. They show this ground station on a handheld radio because they do have a unit that clicks into the back of your radio. So if you're straight above you, rock that antenna over like that so you'll be in its power. This shows if it's flying out away from you, in front of you, you'll be good. Although they call this aircraft up from transmitter, aircraft in front of transmitter. They kind of got their nomenclature here on their diagrams backwards. Oh well. There's not much else to this. Yeah, return policy and stuff, and that about finishes this out with the warranty, etc. Label removed. That's why I don't want to open these radios. I don't want to break a seal or anything on them and cause them to be out of warranty. So this right here is all the wiring information you get. Also, you may have seen when I had the one unit plugged in, it showed the firmware version here as 0.1.4. If we look at the firmware pack that comes off of that site, they look like they're different firmwares for what baud rate you're going to use. That may just be because it sets the baud rate within that firmware, although it may be adjustable. This one may be adjustable to 115.200 after that. I don't know for sure. This shows the version of firmware here is 0.1.4. So I feel confident I have the firmware on the unit that I want, although there's nothing in the assistant that tells you which baud version it is. Again, I think that may just be default setup and can be changed. I don't know. We'll find out someday. So that goes with this. I don't have any need to change the firmware. That kind of completely goes over their PDF file, and everything you find on this page. And again, they were 123.20. Took about 5 to 7 days to get here from China. It was very good. Very, very good. A lot of things in China seem to be being shipped air now rather than by ship. So the ship times are way down. So let's take a look at this information here real quick on the radios themselves. This is the wiring that comes with the radios. There was a 6-pin connector on this end for hooking into a Pixhawk, but I cut it off. I'm not going to be using that. And as you see again, there's a red, a black, a blue, and a yellow. Now then, if we go back to our diagram, it showed red, green. Let me look real quick. It shows the colors as red, green, which is black. So red, black, blue, and yellow going down that connector. That's also another problem, as I was mentioning earlier, figuring out what's transmit and what's receive on this thing, because look at this. On the connector itself, you can see it's red, black instead of green, yellow, then blue, not blue, then yellow. That's why I'm saying, or said earlier, that transmit and receive may be a little different than the wiring itself. The diagram, transmit and receive may be different. Real easy to do things like that. Recently I told somebody to switch the transmit and receive on a crossfire setup, because sometimes you think you've got it exactly right, but you don't. And also sometimes the documentation isn't exactly right and perfect. So I'll be hooking the red to 5 volts, the ground to ground, the black to ground. The yellow, I guess I'll be hooking that to the transmit on the flight controller, and the blue to the receive on the flight controller, but that might be completely different. But it'll be just a matter of flipping the pins around in the DuPont connector. Here's the other end that I'll be soldering on. It's a little 4-pin DuPont connector. Come on, focus. There we go. Little 4-pin DuPont connector. And the flight controller I'm going to be hooking it to has the supply voltage at the bottom and the ground at the top. The way I'll be connecting it. And then I do have a yellow wire in this, but I don't have a blue wire in this. So I'm going to hook red to red, black to black, yellow to yellow, and I'm going to hook this white wire to the blue wire in this connector. And like I say, I may have to pull these little releases up and flip this white and yellow around in this side if it doesn't work from the get-go. Man, while I was doing the editing, I just found a new noise source trying to make videos in this basement. I bought this Mr. Heater gas heater to try to get to the basement and keep it warm enough so I can work down here this winter. And it has a blower in it. And it keeps turning on, turning off, of course, and you can really hear it in the video because the microphone picks up everything it hears, whereas our human ears, the brain, will block out lots of things like that instead of being as prevalent in the videos as it is. I'm going to have trouble figuring out how to keep this running. There it goes. And get around this noise where I can turn the dehumidifier that turns on and off in the winter, stays on constantly in the summer. Also, the furnace that's in the basement just turned on to the right side of me, so it's always something, isn't it? So this is data port 1, data port 2 up near the antenna. So I'm going to hook this into port 1 just like this after I get the DuPont connector wired onto the end of it, and we'll be ready to go. I'll put an antenna on it because these are transceivers. They transmit and receive, and a transmitter must have an antenna on it or you can blow it up. I'm pretty sure the ground and the supply voltage. It's just to transmit and receive out of this. That's the only question at this time. And I'll be putting this in the Datalink EVO, the little small Datalink I have. It has an MRO 2.1 version 2 flight controller in it, and I'm going to put it right down these 4 pins right here, which you'll see is ground at the top like I showed you, with voltage at the bottom, and then transmit receive in between those two. And I'm just going to have to flip it around after I put it in to see which is which here, because again, the diagram shows, God, let's go back to that diagram real quick. So we pretty much already know, oops, that even if this green wire was black, it doesn't match the wiring harness, because on the wiring harness it's red, black, yellow, and then blue. So that makes me wonder if the blue is transmit or if the blue is technically receive. The only way I really know to figure that crap out is to connect it up. And if it doesn't work the way I connect it up, like I say, just change those 2 pins. Doesn't take but 30 seconds or less to change those 2 pins around in that DuPont connector to change where they're going on the flight controller. Ain't that something? Red, black, yellow, blue is what is on the actual wiring they sent with it itself, not in this order. So I don't know if it's VCC, ground, receive, and transmit, with these colors remaining correct for what they're pointing to here, or if the colors are actually reversing that connector. Again, the only way to figure that out, in my opinion, is to connect it and see what happens. Isn't that something? There's my cable soldered up. This side for the telemetry radio and this side for the flight controller. And I chose this wiring scheme on this side, and I'll show you real quick up on the screen why I did that. So I decided to go with what these outputs are labeled rather than the color. So although my TX wire, if it is, in the connector coming out of the radio is actually yellow instead of blue, I chose to see it as the transmitter. Therefore, I put it up in the 3rd wire. Here's my 5 volts. Here's the transmit that goes to receive on the radio, and here's where I put the yellow one, the transmit on the radio going to this receive and this ground. That's the way I did it. I hope you'll be able to see this on the bench here. I'll turn on the ground station, and of course I get the red light. It says it's waiting on a connection. I'll hold it up here so you can see that. And when I turn on the air unit, there's some negotiation, and both the lights turn green. That's the way packet radios usually work. Yeah, I think you can see that green there. They negotiate everything, they connect, they start sending data. There's really not much magic there. So at this time, I'll take this connector. We'll pop it in there, and then we'll go over to the other side of the bench and put it in the airplane. And that's probably going to be hard to see, but it's plugged in right there on that MRO 2.1 version 2 flight controller. 4 wires right there. Now we'll see if I power up the platform. Do I get a red light on the transmitter? I did not get any indication out of the radio with just the USB power. I had to put 16.8 volts on the battery power portion of the model. I'm going to go over right now and power up the ground radio. And I've got a green light on both of them now. Let's see what happens inside the software. I'm going to go ahead and disconnect the USB from this. The USB is no longer connected, just the 16.8 volts. And this is me 3 days later. Yes, I powered it all up and it did not work. And I'm not going to make this video 100 hours long. It's already long enough as it is. I switched the receive and transmit around. I even came over and switched the port on the flight controller around. I moved the physical connection on it from right here on UART 8, which was serial 4 I was working with. I moved it right over here on UART 7, these 4 pins, voltage, ground, receive and transmit. These two are the same right here and right here. This one seems to be set up majorly for telemetry because it has a cleared send and request to send right here in addition to the transmit and receive voltage and ground up here. I've got, I think that's where I hooked the RFID chip on this one in. So I was doing every backflip in the world trying to get this thing to work. My wife thought the circus had come to the house. I was suspicious that the connection here, I've got a 433 telemetry radio connected into this connector right here on the platform. I've got a GPS and an I2C port right here for my airspeed sensor on the front. A GPS is on the front of this one, or did I move it to the back? I think it's still on the front. And this, of course, hooks back to the ground control station when I want to program this flight controller. And this is, there's 3 connectors, 2 here on the top and 1 on the bottom. They show a bottom view of this. No, they don't. Well, that's so very helpful. So I could read here that the GPS was on UART 4, serial 3. But, and I could, this telemetry 1 was on UART 2, serial 1. This is a CAN bus over here on this side of the board. There's 4 physical click type connectors for multi-wires on this flight controller. I guess you might be able to see them up here. Yeah, there they are. This is the telemetry 1. This is the GPS I2C. Down underneath here is where you hook up your USB. Got a little pigtail goes out, and this one on the top is the CAN bus. And I was over here on these 4. 1, 2, 3, 4. And also on these 4. It's hard to see in here. These pins are 90 degrees. You can order these all soldered up, either with 90 degree or straight pins, and with no pins, which is sweet. So, tried to be sure I wasn't conflicting with any of this other stuff, even though down here it should have been pretty straight up. This one's supposedly the OSD, the UART 8 here, serial 4 and R2. They say it's OSD. It don't matter. Here's debug. That's what they say this one's for. 7,
UR7, serial 5. I've never heard of a debug connector before, but I suppose it's possible. And telemetry 2 is UR3, serial 2. UR3, I guess that's this one. No, that's this one, UR2. Where's the other one? Oh, I guess it's this one. Yeah, the one I hooked the RFID up to. UR3, yeah. That's actually telemetry 2. This one's actually labeled telemetry 1, isn't it? Duh. Been long days since I got back to work on this because it was so frustrating. GPS UART4, telemetry 1 again over here, so that pretty much accounts for everything. But because it didn't work, like I say, I switched the transmit and receive around right here to start with, and this port when I had it in that one, and then moved it over here, and of course again I switched it around right here. Didn't help a darn thing. I tried 115, 200, 57, 600. I was more and more suspicious that that was a fixed baud rate in just the code that you put into it when you flash it. So I literally couldn't figure out how to make the darn thing work. I was flummoxed. I mean, the green lights came on both the radios. They connected. There's just no data throughput. So, being the me I am, I just kind of pushed this aside. I kind of put stuff like that out of my mind when it happens. And I just kind of wait for divine intervention. No, not really. I can't delve down on it hard because it'll just drive me crazy if I think about it constantly. So I just kind of ignore it. And my brain will work on it from moment to moment in little ways. So the first thing that came to mind was using a secondary flight controller, the one I have on the bench here.
So, like I say, one of the things I decided to do was attach it to this flight controller. I've got two UARTs. This is a H743 wing. There's a UART right here on these 4 pins. Oh, there's 2 pins right here, and there's a UART right here on this red and white one. So real quick this morning, I grabbed this. This is some of those little connectors I got. These are actually single DuPont connectors on the end of all these wires. And on the other end, I've got the connector that goes in that those radios, a 4-pin. Bummer is, remember I had wiring problems with their stuff. Look at this. This is what I got here. Is black, blue, white, and red. The black one's actually power. The blue's ground. White is transmit, and red is receive. That's why this blue for ground is in this first pin over here. God, whoever gets this stuff when I die, they're going to look at all these color, the way I've got some cables made and other cables made, they're going to just crap if they try to go by this color coding. The blue's ground, that's why it's there. The black is actually power, that's why it's there. And the white is transmit, and this is receive, and the red is receive, and this is a transmit pin out of here. That's the way Baytech did it. They put theirs ground, power, transmit, receive and transmit, which is nice for when hooking up to other things. So that also proves that the white here was a transmit pin and receive, no matter what these color these wires are in that other radio or in this one, you do pay attention to the connector itself, where it shows it on the wiring diagram, and it is voltage, ground, transmit, and receive. So the red wire is going to transmit again on this. I powered this bad boy back up. It's got Ardu plane 440 on it. No, not gonna work. So I had it all right here in front of me instead of having to walk over there to the actual airplane I was using over there. Made things quicker and easier to do. So again, I flipped the pins around, because flipping the pins around on this is a matter of unplugging these two pins, separating them, and putting them right back on. It takes just about that much time to reverse them, because like I say, these are all single DuPont connectors, not a 4. Wouldn't work. So another idea that I'd thought of in the past 3 days while I was just sitting on this and sort of smoking it over slowly. This is that little pack of wires I'm talking about. I don't know if you can see in there real easily. There's 2 wire connectors, 3 wires, not many 4 wires are left in there. I think there may be 1, 5 wires, 6 wires, 7 wires, all that same connector this is used. Reason there's not that many 4 wires anymore, that may even be the last one down there, is I've used it for this business end and cut it off back here before the little single pin DuPont connectors on the other end, and wired it into some of these UARTs behind me in these platforms. I'll try to put a link in the description for this. If I don't, hit me up and I'll try to remember where I got them, because I actually do need to order some more, if nothing else. So I'll have this type of connector I can prototype with the 1-pin DuPonts until I get it where I want it, and then I can cut that off or actually take the pin out of the DuPont connector and solder something else to it. Not the best of cable setups. That's the way I've been doing it.
I did most of this work, the video, last Wednesday, the bulk of it, when I got up Wednesday morning and throughout the day. And one of the things I talked about over there was the baud rate on these things, and that there's firmware for 115, 500, and 57, 600. So even back Wednesday, it was also in the back of my mind to change the firmware on these. Although I was coming in here and changing this between 115 and 57 for the 115-200. When I was doing all my backflips, moving it from UART to UART and flipping the transmit and receive on the UART around. So then, like I say, when I came back to it today, it's actually late Saturday now, about 8:15 Saturday night. I decided to, which again I'd been suspicious of all along, to physically reflash these radios with a 57-600 baud rate. So that's what I did late this afternoon after working with that on that secondary flight controller and flipping the transmit and receives around and all that stuff again, like I did Wednesday for 2 or 3 hours. I decided to reflash this firmware. So again, using their little utility here, get file name. I've currently got what they consider the ground unit, and this is a 57-600 baud of 0.1.4. Merely open that and tell it to upgrade it. It doesn't take it long at all. Works really good. Also, some of the other things I did with these radios was pressing the button on the left side to rebind them to each other. That didn't help at all either. The ground station, you have to use the USB micro connector on the left side of the radio. Let me throw that up on the video here real quick.
So to program up this radio, flash it, put the connector in the side of it here. There's a little bind button that you have to push to bind these together. There's a 3-position slide switch right here in both these radios. There's nothing in the documentation that says the first word about them. So this will be the way you have to connect it to flash it. The utility software doesn't even see the radio if you use a USB like this to connect to it. You can't flash it with this connector, although this connector is the one you use on your ground station when you're flying. So I'm going to set that aside right there real quick. Leave it on, waiting. And I've got the other radio over here plugged into that flight controller. That would be hard to see if you even tried to see it down there. Yeah, actually, you can see it. The red, white, and blue and black in this connector, I think, is the RFID in this. It has a permanent one installed for kicks and grins. And this is the UART one with the supply voltage, ground, and transmit and receive in the middle. Ooh, doesn't want to focus. So we'll put some battery power on this airplane. And when you do, everything powers up and you have a green connection light here on the radios now.
And with all those changes made, when we go in here and pick up the ground control station, I guess I should shut down that USB on this 7 right there. And this is the ground unit. And at 57600, click connect. It was working a little faster, kind of like where it reads that first time through that failed this time earlier, but I'll take this because you can see there's no already gots in this area that we've seen in the past, and it figures out it's on the wrong firmware, or it needs a firmware upgrade pretty quick. That's it. We're connected. I don't have a radio or anything on. That's why I'm getting the radio failsafe. And everything's working. MRO X 2.1. So, those radios for me, and I will go back now and play with them with that 115-500, 200, I think it is, 115-200 baud firmware, just for kicks and grins, because I'd like to see this all faster. But those radios are working now, and we can see now that this was correct. Positive ground, transmit and receive whatever color wire you've got coming out of it, because you see I had some funky ones coming out of it when I connected it to my secondary flight controller to try to work with it there. So just do your own wiring. This is correct. Voltage, ground, transmit, and receive. And the transmit and receive have to be crossed over before they go into the flight controller. So transmit goes to receive on both ends. The flight controller's transmit goes to receive on the radio. The radio's transmit goes to receive on the flight controller. Else they don't communicate. That's all there is to this until testing. This has been such a frustration for me, sitting here for 1 day of work, 3 days of smoking it over and thinking about it from time to time, to finally getting back in there today and getting it working. So, all right, I'm going to publish this video. Thank you